Hello everybody! Welcome to AGACAD's webinar Heating and Cooling Design with Advanced Workflows. I want to ask you to raise your hands if you can hear me and if you can see my screen. You can do that on the GoToWebinar dialog block on the right side of your monitor. So I'm waiting for the raised hands. Okay, I see some of you are raising the hands. Okay. Someone has the question. Okay. Someone says okay. As well, I want to say to you that we have the question tab in the GoToWebinar dialog block, and you can write there some questions during the webinar. And in the end of this session, I will try to answer all of them. So I want to present myself a little bit. So I'm Jakub Sveishvila, HVAC engineer and BIM application engineer here in AGACAD company. So the AGACAD is the company that is operating since 1988, and we develop BIM software and add-ons. Basically, we are working on Autodesk Revit solution, and we are working worldwide. So we create solutions for continuously BIM acceleration based on the experience of the most advanced users like you. So all the time we are waiting for some feedbacks, insights or something like this, and we are creating a new software for Revit, and we are developing the old one as well. So basically our mission is to reduce BIM stress. So we help to eliminate tasks that do not create value. And during this session, I will try to show you how we can eliminate tasks that do not create values in hydronic system design workflows. So in this webinar, we will speak about our heating solution, and you will learn more about hydronic system design within Revit. That will cover both system design, heating and cooling. So during the part of heating, I will try to show you how to distribute heating devices through the building with advanced to calculated heating loads, or just simply distribute them, how to easily connect them into one hydronic system, and how to balance the system. So basically the last point is the most interesting point for the designers that are trying to balance the systems to get the flows equal, etc. And as well, we have the part for cooling. So I just invented a new workflow for cooling, and I will show how to distribute cooling devices such as fan coils through our project really simply, as well how to balance that cooling system and get the needed key values into your project, into your balancing equipment. So our heating is a software for hydronic system auto creation and balance. It contains more than 10,000 radiator types. It can distribute mechanical equipment through the project. It can add pipes and accessories to connectors to the mechanical equipment, and it can balance the hydronic system. So I don't want to speak more literally about this, and I will show you live how does it look like in Revit. So here I have really simple project, just few spaces. It's 7th floor building, few spaces. Each of these space has the calculated heating load, for example, and as the first workflow, I want to show you how to work with the heating system. So Starting with the heating system, we have our heating solution that is placed in our Tools for BIM dock application. So at the very beginning we have to create some shared parameters that will add your balancing information, supply and return pressure drop, total pressure drop, etc. Um, Afterwards, I just want to show you how we suggest to create your library for radiators. So we have integrated, as I said before, more than 10,000 radiators inside of this solution, and we have the most popular manufacturers here in Europe. So we have Purmo, Kermi and Arbomia. Um, Anytime, if you will find it necessary, you can build your own text files from the catalogs, or you can ask us to create the text files, and you will see what happens with them. So it's only the type catalog, the text file, that I opened over there, and if you can see, we have a lot of elements, like about 3,000 of different elements from the catalogs, and they contain a lot of information that designers could need, like it's the flows, pressures, powers, etc., coefficients, etc. So if you will go inside of this one, you will see the connection possibilities of your radiators, like there's the connection down, side connections, etc. As well, you can find that we have power calculated, the flow calculated, and the pressure drop calculated in accordance to supply, return, and the room temperatures. So if I will change some values over there, okay, so for example, 70. So you please look over there to the power, flow, and pressure. And if I'm changing the values of my temperatures, the power, the flow, and the pressure drop is recalculated in accordance to these temperatures. As well, we have integrated valves sometimes in our radiators. Again, if you will look over there, we have the same features over there, that is recalculating KV values, balancing pressure, etc. As well, we have some diagrams in accordance to which we are calculating that KV value. So after you will click OK, everything will be set to those temperatures that you need, and you will be able to save that, for example, on my desktop, radiators family, for example, and I am saving that as the text file. But at the same moment, the tool is recreating the text file into the real Revit family that you can find in Insert tab, Load Family, and if I will go here, I will find that they're not the text file, but I will find RFA file, so I'm opening it. And this will be something like a lookup table that you will see over there. So all the elements are listed over there. Here you can find like filtration possibilities. I will filtrate by some heights, by some type numbers, and I have all the needed information, like the flows, powers, I don't know, pressure drops, etc. So I'm taking all these families, I'm clicking OK. I have more than one family type loaded, and if I will go to the project browser, I will find radiator families over there. So those families are really simple, and you can place just them to the model as you need, and they have the real power, pressure drop, and the flow over there. But I have a little bit easier way of distribution, because sometimes when you're looking at the radiator, they do not have such parameters of the power. So we have created the tool that is named R-Heating that can insert elements by some related objects. So I'm going to that feature, and this feature allows me to choose from all the categories that are in my project. So as the constant thing, we always place radiators under the windows. So if I will choose Windows category to be placed to as a host, kind of host family, I will find such a table. So here I have a filtration possibility, like in accordance to the levels. I can configure that to the space names, families, room names, zone names, etc. And I can filtrate my spaces where I want to place those radiators. Then I go to insert elements, and I'm choosing that mechanical equipment, and I'm going to the family that I just saved before. So here I have listed all my types. I'm clicking on one of them. I'm adding that to my to another side of my dialog block, and here instantly you will see some of the rules. So the very first rule could place radiator to the window center, just the family that you picked. If you want that it will work a little bit smarter, you can distribute radiators on the wall under the window by design, heating load, and window width, for example, or by design, heating load, and minimal ratio. That means if you are working with some kind of buildings that has some requirements like I don't know, like health centers or something like this, so they require you to place radiators that will never be bigger than 75% of the whole of the opening for that radiator. Okay, but I will try to use this one. So just place radiators under the window by design, heating load, and window width. And here we have some parameters like elevation, at what elevation you want to place your radiators, and the power parameter. So I'm trying to insert those radiators into the model. That could take some time. That depends on your building, on the size of elements, on your computer possibilities, and so on and so on. So I'm clicking OK. And right now, what do I have here? You can see that I have distributed radiators under all the windows of my first floor. And those radiators has really nice thing that they have the real power in accordance to our temperatures, the real pressure drop in accordance to our temperatures again, and the real flow in accordance to our temperatures. And as you can see, if I will go into this space, this is room, I need a space. Okay, this is, yeah, this is room, is space. If I will go inside, I have design heating load. So if I will check those radiators, it's 1165 and it's 1165 by 3. I have 3495. And if I will go to here, 3495, so it took a little bit bigger radiators than the space requires. So that means it is choosing the right radiator types to be placed into the space. So if I don't know if that could be possible if you're working with architects, and architects said that here under this window we do not need the radiator because there will be like the window to the floor just to see everything around, and he asks you to delete that radiator. So basically what you should do, you should recalculate those radiators manually, but now we have the feature that is called update all radiators or update room or space radiators, which will update your radiators automatically. So if we will take a look at those radiators, and if I will click on update room space radiators, they will change their parameters. First, geometry. Second, the inner physics parameters. If I will click OK, I will go to my radiator, and I see that one of those radiators has 1665. So that means we have something about 1665 by 2 is 3330. So the space requires something like this. So it is choosing the nearest radiators that it can find in your family types over there. So it is choosing the nearest radiator configuration to your needed space heating load. So this could be done in various ways. You can place the radiators that are near to the windows. You can place some radiators anywhere, connect them, etc. So after you distributed those elements, you have to connect them into one hydronic system. So if I will go over there, I will change the discipline to mechanical, and if you want to connect that into one big hydronic system, you have to draw some pipes over there, like the pipes like this, etc., etc. But we have a really nice feature where you can add accessories and pipes to connectors. So I'm going to that feature, and again I have such dialog. So here it's kind of the same pipeline, and this is return pipeline. So here for the supply you can choose what connector you will use, or what shutoff valve if you have one. So this is balancing, so I'm turning it off. As well, for the return one, you have the same features, like two elements you can add over there, like the pipe connector to the radiator, or as well the pipe accessory like shutoff valve. And here we have the pipe types. For example, I will choose the standard pipe type, and to connect them to radiators, and you can choose the horizontal pipe length. So if you will have connectors that are going left or right from radiator, you can set the value of how what will be the length left or right from the radiator. So if I have them down, just like in my case, I can set what value, to what elevation they should go down from the radiator. So after you will set that, you can save everything, and you can click OK. And as you can see, it is creating the pipes nearby the radiators, and we have 8 pipes added. And if I will go nearby the radiator, you can see that it took that standard pipe type from the project with all the routing preferences inside of it, and it added that element for connection of the pipes. The same here. So afterwards, then you know the elevation of the pipe, and if you know how you want to connect, you can draw your pipes something like this. I'm going to first floor. Okay, I'm creating the same. So you can draw them and just simply use, I don't know, the function to, okay, let's say this one. Oops. Like this. like this, etc. So you can connect your radiators really simply without going into each of those radiators, connect into choosing the connector, one or the other, etc, etc. So that take time, really that take time. So we suggest such workflow. So after the distribution of radiators and connection them into one hydronic system, you will get something like, okay, I will do a little bit like this, a little bit more. Okay, this is something not what I need. So after you connect everything into one hydronic system or two hydronic system or wherever you want, all the time you are able to calculate the pressure drops. So you can do that using analyze tool and the pipe pressure loss, but it's not working all the time. It's not so precise and correct as we want. So what we have created the tool for balancing systems. So you can balance the system from any point you need. Like if you will click on supply and return pipes and you will try to balance the system, it will automatically go through all the system. It will find all the lengths, heights, powers, nominal diameters, pressure drops, total pressure drops, supply and return pressure drops, as well as the main thing, what is like kV value, in accordance to which the guys in the building site will try to balance your system. So you don't need to do that manually to calculate using Excel files or I don't know the other software that provides your manufacturer or something. So everything could be done inside of the same system. So this is really nice. After clicking OK, everything will be written into the parameter that should be created in your family. So kV position, kV value. Yeah, so that's the family thing. And after the balancing, you can I don't know, you can export a legend or sorry, a schedule and share that with your builders. So you can do that from any point in the system that you need. Just remember that if you're working with heating systems, I'm going here to the pipe systems. So I have two cooling and heating systems like return and supply. So if I will go inside, it is taking those values from fluid temperature and fluid type, and it is getting the information from fluid density, and it is inserting into the calculator. So for the return is one temperature, for the supply is whatever temperature what you need. So it is taking those temperatures and it is taking the fluid density from there. So don't forget to work with the normal temperatures that you are working with in the real life. So this is the workflow for heating. The cooling workflow looks really the same. Just one thing that we do not provide the cooling equipment. We do not provide fan coil families. So I just went to some pages and I found some families like mechanical equipment and I don't know, it's indoor units. Okay, this one is it's a cassette fan coil. It's the ceiling suspended fan coil that is placed above the doors, etc. So I will try to use them in my project. So what do I have here? I have ceilings. I am in the ceiling plan. So firstly, I want to distribute my ceiling-based elements into the building. For example, into the first floor. And I'm going to the tools for BIM dock. I'm going to the same R heating solution. I'm going to insert modify radiators. It's as I said, for cooling, it's really brand new workflow that we invented just few weeks ago. And you can insert elements by related objects again. Again, the same thing is here. I'm taking, for example, room. From the first level, I'm going inside, I'm choosing mechanical equipment, and I will choose this one, for example. So again, the same rules are here, but for different elements you can find different rules. So like the rule to place element on the ceiling, place related to room location point. So if you have room location point like this, so it will place the element in the middle of it. Okay, so let's try to do that. I'm inserting that to the model. I have 7 elements inserted, and just check it out. I have elements distributed through my project. So that took me few seconds to distribute those elements, but imagine if you will have a really huge building. So how you will manage with that? You will go through each of the space and place one by one and one and so on. So that will take you a lot of time. In this case, you can insert elements by related objects. Another thing, you can place not only to the ceiling. Okay, I will show you from the 3D view how does it look like. I'm doing like this, and you can see, okay, it's second floor, it's first floor. So I distributed my elements just simply into the ceilings. It cut the ceiling. I will change that to calibrate this coordinate discipline. It cuts the ceiling, and it looks like this. So afterwards you have connectors, and you know how to do the rest of the work. Again, if you have different elements, not the ceiling based elements, but you want to place near above the doors elements, so we have something the same. Again, I'm going to insert the elements by related objects. And I'm choosing, instead of rooms and instead of windows, I'm choosing door category, to which I will try to insert the element. I have to filtrate, for example, for the first floor. I'm going to insert elements. I'm looking for the element. I'm adding that. And I have some rules again. I have element on the wall, place related to the door center or at the door handle side, like electrical equipment, fixture. So here what we have to do is the elevation. So I'm inserting that into the model. I have 16 elements distributed, and if I will go, okay, it's not seen from here. Let's change to the ceiling plan, for example. Yeah, so near to all the doors, I have distributed my my components. So if I will go to the 3D view, okay, my ceilings are too high. Yeah, as you can see, I distributed the elements above all the doors in my building in the first floor. So it's really nice that you can do that. So in this way you can distribute elements in various cases. Like if I will go to the third floor, I will try to do this ceiling. Okay, just this one. I have a lot of doors over there. Just I will try to show you the workflow, another workflow. Okay, I will choose architectural templates. I'm taking the doors and I will add some comment parameter like 1, for example. I can go to insert elements by related objects. I can go to the doors. I'm opening that. I'm going here, the first, but I want to select some new parameters and I'm looking for comment parameter. I'm adding that. And as you can see, I have some comments on there. So I can filter it by selected data. I have all ones on the first and third floor. I am going to mechanical equipment. I'm choosing that element and I'm placing that at some elevation and I'm inserting that to the model. Okay, third ceiling. As you can see, 1, 2, 3, 4. So nearby all the doors that was that was marked in a comment or in your any parameter. So you can distribute them. As well, I just want to mention that the same distribution you can find in insert elements, but it has a little bit more features. Like you can insert elements by related objects as well. You can insert gravity points, you can insert virtual groups, etc. So it's a little bit another talk, but you can distribute the elements in the same way as I showed to you before. But you will be able to distribute a lot of different, for example, elements. I'm taking doors. Okay, I'm taking the first floor. I'm going to electrical fixture and any switch at the door handle side at the elevation of 100 of meters. So I am inserting that to the model. I have 13 elements inserted. I'm going to the first floor, and as you can see, nearby the door, at the door handle side, I have distributed electrical fixtures. So this is the same distribution, so you can find all the elements in the project, the same elements in the project, and add some rule to that. You can create your own rules, by the way. So it doesn't matter how you want to place those elements. So you can create your own rule. So after the distribution of the heating system, we can go to, okay, let's go to the second floor and do the same workflow as I showed to you before. So I'm looking for the starting point of my cooling system. I connected it well. I connected everything, placed the balancing valves, and I'm going to pick the supply and return pipelines. Just take in mind what I'm doing. I have again a little bit different fluid temperatures. So for the hydronic supply I have 7 degrees of Celsius, and for the return I have 12, I think so. So I'm taking those 2 pipes. I'm going to tools for BIM dock, I'm going to our heating solution, I'm going to balance the system, and I'm clicking on the thing to balance the system. Again, the same dialog appear, and I get the key values here, 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 and here. I'm clicking OK. I'm going to any of these elements. I'm going to it, and I see that key value is calculated, and I can just tag that. I can schedule that, etc. So this is really brilliant tool. Just sometimes people ask how it works with a bigger system. So I have a bigger heating hydronic system over there. So let's try to balance it. Again, the same table. You are able to export that to the Excel if it's needed, to check, to report, to add some marks, etc. And that key value is over there. And I'm clicking OK. I'm going to that model, and if I will go to any of these elements, this one is 0. Maybe I clicked cancel. Yeah, let's try to do one more time. Okay, I hope that will work right now. Maybe that do not need to be calculated. Yeah, so the key value of this one is 0.9. Maybe on radiators we will have something as well. It's 0 on the radiator. Here it's 0.94. Here it's 0.822, etc. So it is working. It is working pretty good, and it is using the iteration method to make the flows equal to all the mechanical equipment. And it is trying to write some values in the key that will close or open your balancing valves, and in such a workflow it is trying to make the flows equal. So this is kinda everything what I wanted to show to you and to say to you about the hydronic system design workflow that we have invented with AGACAD team. And here is a bucket of our tools. So we spoke today about R heating and a little bit about insert elements. But I just want to make sure that you would know that we have more of those tools, like cut opening for making openings, smart diffusers for ventilation, smart sprinklers for fire protection design, hangers, sustainable design for calculation of energy. We have structural stuff like wood framing, metal framing, assemblies. We have BIM tree and smart browser that stands for browsing of libraries, and a little tools over there for just a quick how to say, work, like insert of Excel spreadsheets into Revit, sort and mark elements, I don't know, insert elements fastly, etc. So we have a doc, tools for BIM doc, that is one shortcut to all trials, tools, updates, news, helps, and more. So you can find it. You can get it for free for 14 days. Any of our tools like cut opening, R heating, any of these, just writing some your information inside. So if you will go to our web page, you will find download tools for BIM doc. So just click on it and you will find that. So now it's the time for questions, and I'm waiting for your questions before we will end this session. So if you will write some, I will try to answer them. You can do that on the right side of your monitor in the Go to Webinar dialog. EHAP is asking, does inserting elements work on categories in linked Revit models? This feature is working with Revit 2016 because Autodesk improved the linked file possibilities, and now we are able to find elements in the linked file. One more question. Vang is asking how much each plugin cost. So basically, I'm not the salesman. I'm the man who is developing the software, and talking straightly, I do not know the real pricing. So if you are interested in the solution, just write a short email to the support at aga-cad.com, and we will try to not try, but we will send to you the price list. Mohammed is asking, is it able to work with flexible pipes? What do you mean, is it possible to work with flexible pipes? Do you mean you want to calculate the KV value, like to balance the system, or what? Could you explain a little bit your question? Thank you. Kyle is asking, can you place more than one mechanical equipment into space? Yes, you can do that. If I will go, for example, to the Revit, again to the same project, I will open some, okay, third floor heating. I don't know. So I'm going to the tools for BIM. I'm going to insert elements to the space. Okay, I choose the pipes somehow. Okay, I'm choosing the space. I'm clicking OK. And here, okay, the third level, okay, only to the salons, filter by select data, insert elements, and I will choose, I don't know, maybe plumbing fixtures. Let's say this one, water closets. So I have 3 elements, and I will try to insert elements on the level at the elevation 0. So I have 87 elements inserted. Okay, that was, okay, it's heating. I'm going over there and I'm trying to find something. Discipline, I took the plumbing fixtures, I think so. Yeah, so I'm turning them on. So I have 1, 2nd and 3rd element. So as you can see, it is possible to distribute as much as you want, but it is always placing at the midpoint, for example, of the space. So that's the rule. So you can do some offsets, right or left, etc. Thank you for the question about these placements of several elements. Mohammed is asking, I want to distribute my system with flexible piping category. Can I apply the balancing on flexible pipelines? I'm sorry, I know it is not common in Europe, but is very common in the Middle East. Okay, Mohammed, I have to test that because I never tried this one before. And I just have to make sure that the flex pipes has the same ability of the flow calculation, etc. But I think right now that it is possible. Okay, I'm going further. Mohammed, if you can write an email to me and remind me about this question, that would be brilliant. You can do that by writing straight to me, Yokubas at aj-cad.com. So you can write the question just now, and I will test that, and I will answer, and I will give the answer to you. Ihab is asking, hello again. Why FCUs are not provided when the tool is used for cooling systems? Uh, what do you mean FCUs? Could you explain a little bit? Okay. Why the fan coil units are not provided when tool is used for a cooling system? So I don't know. Basically, we just invented this tool for heating systems, and during this period, I just thought that this is possible to work with the cooling systems as well as the heating system. So we tried this. I tried this workflow just a few weeks ago, and it is working. So that's why I decided to create such theme of the webinar. And we do not have fan coils, but you can find those fan coils in your, I don't know, in the libraries of Revit families. Yeah. Okay, Kyle is asking, can place 5 offs, or does it place 1 off per space? Can you place 5 baths in one room? I'm not sure. I never tried. Let me check. Okay, I'm taking the space. Okay, this one, the bigger one. I'm going here. I'm going to insert elements. I have that space. I'm going to plumbing fixtures, bathtubs, for example. And layout value, it's 5. Insert elements. No, just 1. Okay. I think it should be possible. It requires some programming from our side, and if you will, if we will be sure that you will use the tool, we will add such feature. Really, we will add such feature. Valentina is asking, is it possible to place different numbers of elements in space, for example, depending on space area? So how do you imagine the distribution? Like if you have 100 of square meters, you want to place like 6 elements, and if you have 50, you want to place like 3 elements. Am I right? I'm not sure if this is possible right now, but as I said in the beginning of this webinar, that our tools basically are created in accordance to our customers' needs. So if you need that, and if you want to work together with us, we can create such tool, and we can create such feature in this tool. It's not a big deal. So just contact me again with the same email and the same question, and I will try to communicate with you. Ehab is asking, so is it possible to integrate this workflow with any Revit families that have the correct parameters? Yes, Ehab, it is possible to work with any families. So as you can see, those I don't know, those elements are just just simple Revit families, just basic Revit families. And yes, it is possible to work with them and to balance them just inside of them. Like if you want to balance the system, you should have some inner parameters of the pressure drop, for example. So we are giving some material here in the help, some material of the technical documentation, some material of the sample projects, and you will be able to try that by yourself. Do not hesitate to contact me if you will find something. And again, I want to remind you about our webpage. It's aga-cad.com. You will go to the project products, our heating, so we have all the descriptions, we have all the getting started videos, and the free trial, it is laid here. Okay, so I see that you are trying to leave the webinar, so I want to say thank you for all the attendees for your time, and I hope that was really informative and helpful for you. And if you will need something from our part, from our side, just contact us by the emails that are provided here. So have a nice day and goodbye. See you next time.